I'm Dr. Padilla. I'm a professor of computer science and psychology, and I study how people reason with the data visualizations. I wanted to talk to you today about a topic that I think has gotten some pushback online, and I see a little bit of misinformation about this topic. So I thought I would clear the air and describe to you what are dual encodings and should you consider using a dual encoding. So let's start out by discussing what in fact is a dual encoding. We've discussed what encodings are in previous videos. It's essentially where you take raw data and you map it onto a visual variable like color, texture, line, etc. That's what an encoding is. A dual encoding is when you take the same raw data and you encode it to two different variables. So in some ways it's duplicating the encoding. You're representing the data twice in the visualization. Let's look at some examples. Here we have a dual encoding where we have the positive and negative valence of these different words here on the x-axis, and here are the different words, and you can see kind of a distribution of the average scores. Now the primary encoding for the valence of these words is position, where they are along the x-axis here. This visualization has a dual encoding because position is also encoded with color, where we have more negative words in red and more positive words in green. So in this way, the same data is mapped to two different visual encoding channels, as we would call it, position and color. Here's another example from the New York Times where we have a dual encoding. The positive values are encoded with orange and the negative values are encoded with blue. You could get that same information from the height of the bars here and the lower bars here, but it has two ways of representing the same information. So in some ways it is redundant, but in this case it's actually quite useful because it can give you a very quick way of seeing positive values and negative values, and it highlights what the designer wants people to focus on. If you take a raw value and you encode it twice, that is showing you have extra emphasis upon this value, and you really want people to understand it effectively, so much so that you are encoding it twice. Let's talk a little bit about the misinformation associated with dual encoding. There are many different guides out there, and even some books that will say never dual encode. For example, I pulled this from a blog, and this is the 10 commandments of data visualization. And one of them is, thou shalt not double encode. Here's an example of double encoding. And the reason that people say not to double encode is because it is redundant. In this example, we have color encoding the different profit, and profit is already represented on the y-axis. So there's no real necessary reason to encode it twice, okay, in this case. But what we learn from research on data visualization is that dual encodings can really help, in part because they really emphasize certain variables. The trick is that you need to ensure that when you are dual encoding information, it is not distracting, it is supporting the goals of the design. Let's look at an example of a bad dual encoding to illustrate what not to do. And here's a visualization where we have the different elements on this axis represented in color, and it's a dual encoding because we should know what the value is based on its location on this particular axis. So it's a dual encoding, and part of the reason why this is not effective is that it is not helping us interpret this visualization. It's in fact adding to the visual clutter or the visual complexity of the visualization. And that is a big reason why people say not to do dual encodings, because oftentimes what it's doing is just adding useless, needless information to a visualization. And it creates another layer that people attempt to interpret. So they're trying to figure out, what do these colors mean? Where's the legend for the colors, etc. When you do it effectively, it is supporting and reaffirming the encodings that already exist. And I will say, if you're looking at many of the bad visualization examples online, most of them are issues with dual encoding where people, usually with color, add too much color in a visualization and it makes it completely uninterpretable. Let's look at some examples where I think people have used dual encoding very well. Here is a fantastic visualization that has won some awards. And these are two components of the same visualization. It was a long infographic, and so I'm showing you the top and the bottom portion. Now, let's just take a moment and try to think of what the dual encoding elements are in the visualization. So I want you to pause the video and try to figure out where the dual encoding elements are. Okay, did you find them? Okay, so what's going on here is that for both of these visualizations, the primary dual encoded element is the color. Whereas you have more of these stacked coins, the color changes. As the greater the stack, the kind of brighter the color is. You can see it over here. And what it does is it emphasizes the very tall stacks. I would argue one of the major goals of this visualization is to highlight the states that have these higher state minimum wages. And so that is really what is happening here with this color. Is the color necessary? No, not at all. You can look at the height of the stacked coins and get the exact same information. So it is fully redundant in this case, but it is emphasizing a point with this dual encoding element. Now there is another dual encoding element that you might be less aware of in this visual. It's a little less obvious, and it is the labeling. All of these different coins have the state label, and that is a dual encoding because the state itself geographically is located where the state should be. So that is giving you enough information to figure out where Colorado and Texas is, but then the addition of the abbreviation for the state is a dual encoding. So the reason why this is effective, where the other types of dual encodings that we saw are ineffective, is that it's providing us information that can allow easy immediate interpretation of the primary message of the visual. It is really kind of hitting you over the head with this information and trying to do so in an easy way. If we look at these kind of states over here, it would be almost impossible to understand which state this stack was coming from. So in this way, the individual labels really helps us effectively interpret this visualization, but it of course is a dual encoding. Here's another example of an effective use of dual encoding. This is simplistic, but I wanted to highlight that this would be considered a dual encoding. What I'm looking at here are the different labels when we have the different proportions. So what is going on is you have the bars to indicate the overall proportion, and the bars should be enough information for you to understand the relative proportions. But if you don't want to go through and try to visually calculate the proportions, it provides the number for you. It is a dual encoding and a very effective one at that. The nice part about this is you don't have to do any work. You can visually compare the overall size of these different elements, and then you can easily look at the number to extract explicit values. So this dual encoding is very effective. And the last one I wanted to highlight, I think, is one of the most powerful and subtle examples of dual encoding. Here we have an illustration from the National Geographic that is of the death of the Titanic, and it illustrates how the Titanic sunk and what happened as it went underneath the sea. I'm going to zoom up on it and we can look at different elements of this. So it begins with the boat hitting the iceberg, and you start to see what happens as it sinks below the water surface. Then it breaks apart into several pieces, slowly hits the bottom of the ocean. Now, when I zoom back out, if we look at this as a data visualization, which is what it is, notice that there's some things happening as we go below the water surface, and it's illustrated right here in this smaller graphic. As we're going below the water surface, moving our way down, the color actually begins to change. The color treatment up here changes to down here, and it is reflected in this visualization here. So we kind of have this icy seafloor coloring that is happening that is different than the bright sunny illustration at the surface. This, in fact, is a dual encoding. It is encoding the depth of the boat as it goes down to the bottom of the ocean. What this is illustrating is as you get lower and lower in the sea, down towards the sea bottom, it is cold and remote versus higher at the sea surface where there's more color. In this way, this illustration is dual encoded with this color change over time that is represented in the data itself and is explicitly done so. The first time that I saw this visualization was in a book, and it is this full multi-layout printout where you can really go through and look at the different phases of the sinking of the Titanic. And it gives you a very visceral, kind of compelling storytelling approach where the information is dual encoded. And this is from a fantastic book called The Atlas of Information Graphics, and I encourage you to take a look at it. It has a very good price on Amazon right now, and I'll link in the description the Amazon link to this. In this video, we learned what dual encodings are and how to use them effectively and ineffectively. The main rule of thumb is that if you are using a dual encoding, it can really help reaffirm the primary messages of your visualization, but you need to use them carefully and not arbitrarily. If you're not trying to convey additional meaning in a visualization, you might not need a dual encoding. I hope this discussion of dual encodings are helpful. There are reasons to use it, and there's reasons you might not want to use it that we discussed. If you have any more questions about visualizations, please comment down below. I'm happy to make additional videos that cover specific topics. Thank you so much for watching, and take care.